Today we take a break from the machine learning course, but don't worry, it's still very much related. A good chart component is just such a useful thing in general that I decided to make this as a standalone video. We used it in the machine learning course to plot our features, but today we'll generate some fake data to work with. Our chart will allow to drag and zoom the data with the mouse and style the points using transparency, colors, emojis, and I'll even teach you some image processing techniques to recolor the emojis. It's crazy, you'll see. It also supports hovering and selecting like this, so the list on the left moves as well. This behavior is bidirectional, meaning that if you click something in the list, the chart will update to show that sample. Now, to implement the chart, we'll need to use some math, especially interpolation a lot. I'll start using it in the very beginning when generating the data. If you understand what I do there, great, you're good for the rest of the project. Otherwise, maybe watch my math-related videos first. These things are really useful for other projects as well, so do have a look if you want your skills to go off the charts. Get it? Because we make the chart No!
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Let's begin by creating an HTML file to demo our future chart. And we start off with basic HTML. Let's set the title in the head section to custom chart. We will be able to customize this chart quite a lot. And I'll link here an external CSS file that we will use to add the style.css. Let me close the head section, and in the body section I will add an h1 tag for the title of the page, custom chart, and let's add here a div with ID chart container. This is what's going to hold our chart. And I'll also add here a table with ID data table because I want to create and visualize some data also in a table form. Let's now close the body, close the HTML as well. Let's create our style CSS file and add a quick style for our body. I'm gonna put an Arial font and let's set a blue background color. Let's set it to sky blue. And a margin of 0. I don't normally like margins. Save the file and let's see it in our browser here. So the elements we added are there. They can be seen here in the Elements tab. The H1 is visible also on the page, but there's also the chart container and the data table. They are just empty for now. We are going to be creating the data next, and for that we'll use a bit of math. So let me go here and import an external JavaScript file, math.js. And here we will begin to write some mathematics functions. I will create the file math.js, and inside of it I will start by creating a math object like this, and our first function will be lerp, the linear interpolation function. All it does is given a range from A to B and a parameter between 0 and 1, or you can think about this as between 0 and 100%, and it will output a value between A and B according to that percent. So the function looks like this. I have a separate video on the topic. It explains it in much more detail. But basically, when t is 0, this whole thing here becomes 0. So you just get A. And when t is 1, then this minus A here cancels out with plus A, and you just get B.
and otherwise you get the difference between a and b scaled by that parameter and you add it to a. So you get the value between a and b according to this floating point offset. Let's go back to our demo page and use this lerp function inside of a new script tag over here, and we will use it to create some fake data. We will generate 1000 different samples. I'm going to store them in this samples array, and using a for loop between 1 and n, I'm going to start generating data, and our data will be cars. They will have a type, if it's going to be a basic or a sports car, and I'm going to decide this at random. So I will set the type to be a random value. Math.random returns a value between 0 and 1. So if I'm going to check here if it's less than 0.5, then this is going to give me a 50-50 probability for it to happen. And in that case, I'm just going to return basic. Otherwise, I return sport. So I'm using here the ternary operator, and depending on the random value, I'm going to return either basic or sport. And I want my cars to have other kind of information as well, like how many kilometers they have driven. And I'm going to use the lerp function to generate a random value between 3,000 kilometers and 300,000 kilometers. And our last parameter will just be math.random, which naturally outputs a value between 0 and 1, so we're good. And lastly, I want a price for our cars to be decided also using the linear interpolation. So the price will be between maybe 9,000 and 900 euros. So these are second-hand cars, obviously. And the offset is again going to be a random number between 0 and 1. Now I'm going to push in the samples array a new object with an ID I, a label type, and a data point with two values, the kilometers and the price. I'm using an array to hold these two values. Now let's close the object and the function call. Let's check if this code works, and I'm just going to log these samples right here. So we can see these samples in the console, and they are 1,000 of them, and their IDs start at 1 and they go all the way to 1,000. Their types varies randomly, basic, sport, and so on. And this last column here is that array with the two values. We don't see the actual values when we're printing like this, but they are there. We could also log that point here if we want and say samples.map, where each sample is going to be remapped to the point instead. So if I'm going to save this and refresh, we get our table here containing just the two components, the 0 and 1 index in this point array. So these are the kilometer values, and these here are the price values. Now I'm going to remove this logging from here, and let's try to visualize the result in this data table we created. So I'm going to write header is equal to data table create t head. So this is going to create the header section of our table, and I'm going to add a row to this header like this, and in this row I'm going to add a cell to store the ID as inner HTML. So I'm going to copy this 3 more times for the type, kilometers, and price, and edit here type km price. Let's save this and refresh. And we can see here this header section of our table displayed on the screen. I'm going to create the body next and say body is data table create t body. And to populate it, I'm going to loop through all the samples like this. So for all the samples, and we will refer to each of them using sample, I'm going to say create a new row in the body this time. And in this row, let's insert a cell with the inner HTML, the value of the ID of this current sample. And again, I'm going to copy this 3 more times, once for the label of the sample. That's how we called it right here. It's the typical name. And once here, we are going to put point of 0. So this is the value of kilometers, the first value in this point array, and then point of 1. Let's save this, refresh, and here we see our data now. It looks a little ugly, doesn't it? So I don't think we need all of these decimal values. I think we can do without. And to help format these, I'm going to go to Math.js and implement a function, a helper function, math.formatNumber. N is the given number, and let's have another parameter here for the number of decimals we want to use. And I'll default this to 0 because I think it's going to be used quite often. And I just return here n to fixed using the value of decimals. Now let's save this file, go back inside of demo.html and add it here for our data points. Refresh, and now it looks much better. But let's add a little bit of styling to this table. So I'm going to go to Style CSS and right here for the table and the cells, I'm going to say a border of 2 pixels, solid, white. And let's put a padding of 5 pixels and align the text to center, like this. Now, if I save and refresh, we will get this weird kind of layout with this double border happening here. You can get rid of that by typing border collapse. And now it looks like this. Let me also add a style for the head section and set the font weight to bold. I think it needs to look a little bit different. Now, to get an idea of how this data would look like if plotted on a chart, I'm going to copy it and paste it in Excel. And now I'll select these C and D columns that I want to plot and go to Insert this scatter plot. And this is the kind of thing that we'll be building today in JavaScript. But let's visualize this a little bit better and add here some titles for these axes. So this here is the kilometers, and this here is the price. And you would really expect these to be related somehow, like if the kilometers are more, then the price of the car is going to go down. So let's change our math functions that construct the data to do that. The problem is that the way we calculate price here as a random value between 9,000 and 900 should really depend on this km. So it would be nice to have a function that, given km and the interval it's inside of, outputs a value between 0 and 1. And that's what inverse slurp is for. It's going to be a new function that we implement that, given a value within this interval, outputs a t value that we can input here, like so. Let's implement this inverse slurp inside of Math.js below the lerp function, and it's just going to be inverse lerp, again a range between a and b, and a value this time that is a value between a and b. And the formula for this is going to be v minus a divided by b minus a. And that's it. Also a simple function. So what happens here is that because v is between a and b, v minus a is essentially going to make a v between 0 and b minus a. And when we divide by b minus a, then that maximum value, b minus a, just becomes a 1. It's the maximum value. So this should work now if I save the file and refresh the page. Now I copy all of these values again to Excel. And look at that, perfect correlation. Now, this is not how things are in real life. There are many variables that can change the price of the car, and we'll handle that in a sec. But before, I want to teach you something about these lerp and inverse lerp functions. You see, these two steps here applied to obtain the price from the kilometers, first doing an inverse lerp and then doing a lerp, are commonly referred to as remap. And that's one function that we can extract and add to our math library. So we could calculate the price also this another way by typing price is equal to math remap from a given interval, which is 3,000, 300,000, these are the kilometer values, to a new interval, 9,900, and we specify here the kilometer value as such. So this is going to be the same as these two lines from here, but written more neatly. And what we have to implement in this remap is a lerp of a inverse lerp. So let's remove these lines from here and go to the math.js file and implement here math.remap from an old a and old b, the old range, to a new range given a value between old a and old b this time. So what we return here is a lerp with new a, new b of an inverse lerp between old a, old b, and the given value, like this. Let me close this function, save the files, refresh the page, select everything, paste in Excel, and essentially the same thing is here. Let's add some variance here. We go where we calculate the price, and at the end here we are going to add a value between minus 2000 and 2000, and this is going to be a random value. We don't know what are all the variables that affect the car's value. So let's save this, refresh, select everything, paste in Excel, and now we get something like this. Now, interesting to see here that we actually get some minus values for the price. I'm gonna leave it like this as a joke, because maybe a car with so many kilometers, the seller has to pay you to get rid of it. I want to add one more thing here. So plus, open parentheses, and depending on the type, if it's basic, we do nothing, but if it's sport, we add here 5,000. So just to have a little bit of a more interesting plot over there. Save, refresh, select all, paste in Excel, and we get this. And I'm happy with it. Let's continue to implement our chart. We'll go here, below defining our samples, and start to write chart is equal to new chart. This will be the component that we'll implement, and it will take 3 parameters. The div where it will be generated on, this chart container from here, and then the samples that we want to plot, and also some options for visualizing. As I said before, it will be a custom chart. So these options will be something like this. Let's try to define some of them over here as an object, and the chart will have a size in pixels. It will be a square aspect ratio. And then the axis labels, let's write here kilometers. I'm going to try to have a longer text this time. km was too short and I want to see how a long axis label looks like. And price. And then the styles, let's say that for the basic cars we will plot them using gray, and for the sport cars we will plot them using red. We didn't do this in Excel before, but we will customize it to work with those as well. Now we'll implement this chart in a new file. So let me first quickly import a new file here. It will be called chart.js. And now here, let's create it, chart.js. And inside of this, I will use class syntax. So our chart will be a class, and the constructor will take the three parameters: the container, the div in which we put it in, and then the samples and these options. And let's take care of the samples first. I will say the samples attribute is equal to the samples that come from the constructor, and then the axis labels are going to be from the options axis labels, and then the styles are going to come from the options styles. I'm just storing the values coming from the constructor here inside of the object as attributes. Now, to draw the chart, we will use a canvas, and I'm going to generate this canvas by calling document create element canvas, and I will set the width of the canvas to the options.size, and the same for the height. It will be a square chart. Now let's also give a little bit of style here, and I don't want to define this in CSS because I want this to be kind of a component that works independent of too many external files. Style, and then background color for this chart, I want it to be white. I'm gonna append this to the container specified in the constructor, and this should already be visible. Let's save the file, refresh the page, and here it is at the top. Now I would like it to actually be on the right here and to be always visible when scrolling the page, when looking through this table. And to do that, I'm gonna go to style.css here, and let's define a style for this chart container div. So we're referencing this by ID, and we write hashtag chart container, and we'll set the position fixed. This means that the scroll won't affect it, and the right is going to be a 0, so I'm going to glue it to the right side of the screen, and then top is going to be 50%. Now, if I'm going to do this and leave it as such, it's going to align in the middle of the page vertically, but the top part of the chart. So I also want it to translate upwards 50% of its height. And I will do that using transform translate, nothing on the horizontal axis, but minus 50% on the vertical axis. Let's close this, save, and refresh the page. And now you see the chart here. And as we are scrolling the page, it's always going to be visible here. Let's go back to chart.js and do a few more things here in the constructor. I want to have a reference to the canvas context. We will use it to draw things later, and we get that by calling getContext2D. like this. And the chart will have a margin. So this margin will be the space under the axes. And I'm going to set this relative to this size value. So I will set this to be size times 0.1, like 10% of the size. Let's see how this looks like. And because these data points are quite many and they are overlapping, I'm going to support also transparency in this chart. So let's set the transparency value to 0.5. We'll start drawing the points soon, but before that we need to understand that there are two spaces here. There is this data space, these values here in kilometers and price, and this pixel space here. The pixel bounds of this space are easy. They are like depending on that margin and the size of the canvas. But the values here, the bounds for these, are huge. They somehow need to be converted into this pixel space. And for that, I'm going to create two objects here that are going to help. This pixel bounds, and we will get these by calling a private method that we will implement next, getPixelBounds, and we will also have an object for the data bounds. These will be really useful in writing good quality code. And then we can call draw because we have these bounds established. But we need to next implement these three different functions. Let's begin with getPixelBounds. It's the easiest. So private methods start with hashtag and they will only be called within this object. We don't have external access to these methods. So getPixelBounds, we begin by destructuring this to get canvas and margin here. We do this because I don't want to repeat this all the time when I'm typing this canvas, this margin, this canvas, this margin. So in this way, we can just type canvas and margin here. And the bounds object that we are going to return is going to have a left, which is equal to the margin, and a right, which is equal to the canvas width minus the margin. I'm going to have the margin on all the sides. And then the top is the margin, and the bottom is the canvas height minus the margin. So let's return these bounds. Now I'm going to move on to the data bounds. And this is going to be a little bit different because it depends on the samples. I'm destructuring here this to get these samples, again, not to repeat this dot everywhere. And here, let's get the x values and the y values separately. So now the x values going on the horizontal axis are going to come from the first value inside of our point. And the same thing happens for the y, but we use point of 1 here instead.
Now what we'll need is the minimum and maximum of these values.
And I can call here the math functions minimum and maximum, and I'm specifying the whole array as parameter here, but I'm using the spread syntax because these functions don't work with the array parameters. They work with individual parameters, and the spread essentially transforms this array of values into multiple parameters that can be sent to min, max. And these are our bounds. I'm going to return this object. And I could have written this much more shortly, but I wanted to have it like this so that it's clear what these values are. Next thing is the draw method here. So let's implement it below. And again, I'm going to destructure here the context and the canvas from this. And let's begin by clearing the canvas. So this will be useful later when we want to redraw when something happens. So it's a good practice to start with the fresh canvas when we draw everything. And I'm going to clear rect from 0, 0 to canvas width and canvas height, the whole canvas. And then I want to include this transparency from here, and I will do that using CTX global alpha. I will set it to this transparency. And now I can draw the samples. And I reset the transparency to fully opaque so that if I draw something afterwards, it won't be transparent as well. So this draw samples is going to be responsible for drawing that, but this draw will do more things later, like the axes and maybe some other things as well. You'll see. So let's implement just this draw samples function here. Draw samples. And I'm going to destructure more objects here. I'm going to say the CTX, the samples, and also those bounds we computed previously. From this. And now let's loop through all the samples. I'm going to say for sample of samples, I'm going to get just a point. So our samples have also the label there, if it's a basic car or a sports car, but I'm just interested in the point. So I use object destructuring here, like this. We need to calculate the pixel location of this sample so that we are able to draw it. And for that, we actually use the functions we created earlier. So we just do pixel location is a new array. For the x component, it's going to be math remap using data bounds left, data bounds right. Let me put this here. And pixel bounds left, pixel bounds right. And the value, the original value, so point of 0 for the x. And I'm just going to copy this for the y value and replace here left with top, right with bottom, left with top, and right with bottom. And here, instead of the first coordinate here, we go to point of 1. And to draw this sample point at this pixel location, we are going to implement a function in a new file called graphics.js, and that's just going to draw a point with the context and this given location. So in demo HTML, I'm going to go up here and create a new script tag with graphics.js, and let's create graphics.js. And this is going to be another object like this where we are going to be adding functions into, and we will say the draw point function has the context, the location, and let's set here a default color for the points. We'll use multiple colors later. And let's set the size also default to 8. Inside of this function, we begin a path, and then we set the fill style to the given color, and we arc to the location. And because this is an array with 2 values, we can just spread this array into 2 values. The arc method here expects x and y separate, and we are giving it 2 different values. Followed by the radius, so this is going to be half the size that we want our circle to be, and then 0 math pi times 2. So this is a full circle specified in radians, from 0 degrees to 2 pi radians, or 360 degrees. And fill. We save this, and now finally refresh, and this is our data. And because of the transparency, you can see that sometimes regions look a little bit darker because multiple points overlap. Now this is missing the axes, but before we do that, I want to teach you something that will make our code even better in the future. Here, where we remap both coordinates, we will be doing this quite often. So we should extract this as its own function. It will be called remap point, and then our new syntax will just look like pixel lock is math remap point from the data bounds to the pixel bounds, and we pass the whole point here. Let me just cut all of this part from here. It's in my clipboard. I'm going to save this file, go to math.js, and here let's start typing math remap point from the old bounds to the new bounds using this point. And inside I'm going to type return and paste this from my clipboard, but I need to remove this part from here. Okay, and these data bounds, pixel bounds, need to be changed to old bounds. So data bounds becomes old bounds everywhere, and pixel bounds becomes new bounds everywhere. Refresh, and this looks exactly the same as before, but the code is much nicer. Now let's implement a function to draw the axes. And I'm going to call this function here. So before plotting the points, I'm going to say draw axes. It's going to be another private method. And let's implement it here. Draw axes. Again, let's extract some variables. So ctx, canvas, axes labels, and the margin we will get from this. And also, to make the code nicer, I'm going to extract the left, right, top, and bottom from the pixel bounds. I don't want to type this.pixelbounds.left everywhere. I need to type in left. And then we're going to call a function we need to implement in the graphics file. So this will be draw text. I want to use this function to draw the label. So the label on the x-axis first. And the location is going to be half the width of the canvas horizontally. And the vertical location is going to be the bottom plus half the margin. So I want to align the text in between that remaining space at the bottom. Now let's go to our graphics file. After we save this file, we go to graphics and say draw text on the context. And here I actually want to specify some more options, but I will group them in an object because it will make our life easier in the future. You'll see. So let's group here text, location, and then few others. There will be quite many options for this function. So align, which is going to be set to center. Vertical align, I just call this V align, set to middle. And then we have the size, how big we want the text to be. And the color, let's default this to black. And I think that's it. Inside of this function, I'm going to say ctx text align whatever the align value tells us. Text baseline is used for the vertical alignment, so let's set this to V-align. And then a font, I'm going to use bold and concatenate here the size that we have as the parameter. This value is in pixels and Courier font. Now the fill style will be the color, and we call fill text with the given text at the given location, and because this is an array, we can spread it to the two different values. Otherwise, the fill text method of the Canvas context expects two parameters here. And you can see the value here in kilometers. It's quite small. I would like this to actually not be a fixed value like this, but I would like it to come depending on how large the margin is. So let's go back to chart.js, and here we can specify now also the size, and let's set it to the margin and see how it looks like. Now, before I test, see how here I can specify text, location, size, and if I go back to graphics.js, I have text, location, align, v-align, size. So I'm skipping the order of these, and I can do that only because I'm using an object here as the parameter. So this is one of the reasons that we do it like that. We have many parameters here, and sometimes we want to skip some of them. And now this is much larger here. Maybe it's a bit too large. Let's set it to something like 0.6 times the margin, like 60% of the margin. It's a little better. I think it will look good later when we make the chart larger. Now I'm using this small screen when testing, so later we will have the full screen to work with. Let's do the same thing for the vertical axis here, and we will write rotated text here, so the syntax will be a little bit different. We will say save the Canvas context, and let's now translate to the location first. So we will go to the left, but minus half the margin where the middle of the text is going to be. And vertically just half of the canvas height. And now we call the rotate method with minus 90 degrees, or minus half pi in radians. And now we can call the draw text function that we implemented. And we specify the text to be the other axis label from 1. The location here, we can specify 0, 0 because we already translated to that location. We needed to do it in this way because this rotate works related to this translate location from here. And now the size, let's set it to margin times 0.6 as before. We also need to remember to restore. This step is very important because if we don't do that, whatever we draw afterwards will be translated and rotated and everything gets messed up. So let's save this, refresh, and this is just great. All we're missing is some dotted lines here. Let's do that. Say begin path, and we move to the top left location, so left top, line 2, left bottom, and line 2, right bottom. If you want to draw the full rectangle, you can do it, but I think these are enough. And let's use a dashed line. So I will set line dash to 5 and 4. This means 5 pixels for the dash itself and then 4 for the spacing. Line width set to 2. And let's make it light gray in color. And now we can stroke which actually draws the line. And let's remember to set this line dash back to the default of nothing. Otherwise, future lines will be affected by this if we draw any. So let's save this, refresh, and here are the lines now appearing as well. Next, we'll draw some values here on the edges of these axes so that we know how many kilometers or how much the things cost. And soon we'll add interactivity here and we'll be able to drag this data around and zoom it. And because of that, these values will change, but they will always be where the pixel bounds are. So we have to keep that in mind when implementing this. I'm going to go here and use the remap point function and convert now from the pixel bounds back into the data bounds. But for those extreme values, like where is the leftmost point here and bottommost point and rightmost point, bottommost point, and so on. So you'll get what I'm talking about. Just wait a sec. We get the data minimum values, and they will be on both the horizontal and vertical axes by typing remap point between pixel bounds, from the pixel bounds to the data bounds, and we pass here the point of left and bottom. So this will contain the information for this point right here, left and bottom. And we will use this location to draw text using our function from graphics on the CTX, and we will put here the data min of 0. So this is the value of this left after it has been converted into the data space. And the location will be at left and bottom. And the size, I want a bit smaller text here, so let's also make it relative to the margin. That way we don't have to worry about parameters, too many parameters. And let's close and save this. Refresh. And this is the value, the minimum value of kilometers here. But it's this floating point representation that is so large it doesn't really fit on the screen here. I'm going to format this to have some decimal points there. So here, before adding it, I'm going to say math.format number, and then I will specify here 2 decimal points. Let's save this, refresh, and now it's better, but I would like it to be just underneath this 0, 0 point. So we need to be passing here some more parameters, align left and v-align top. Because now align is center, so that's why it's exactly here at the center point, but if we align to left, the text will just go that way, and v-align top means that it will start at that line. So let's now save this, refresh, and it's exactly where we want it to be. We can do the same thing now for the value here, which will be the minimum price value. We already have that coming inside of this data min because we passed the bottom there, and we can use it as such. Again, with the rotated text printing method from previously, we translate first to this same location where we are about to do the printing, and then we rotate by -90 degrees. And now we draw text on the context, and let's pass here the properties. The text will be format number of data min of 1 this time, and the location will be 0, 0 because it's already handled by the translate method. And the size, same 30% of the margin. We align also to left. And vertical align is going to be bottom this time. Now it's a little bit confusing because vertical align will mean now horizontal align and bottom is towards the left. But if you are confused about this, try playing a bit with the values and you'll understand how this works. Oh yeah, restore, very important. Let's save this, refresh, and this is that other value. And it's a little bit hard to see because this chart is so small, but later when we plot this larger, I don't think it's going to be a problem. So even now I can read it a little bit. It's minus 753.05. It's that negative price I made a joke about earlier. Okay, now the maximum values of the data. And for those, I'm actually going to use this same remap point function, and I'm going to pass this top right point instead, because it's going to contain the x value that I'm interested in and the y value that I'm interested in. So this is pretty much a copy paste. I'm going to copy everything here below. And this here is going to be data max. Now data max has to go where data min was. And this code from here is going to print the horizontal rightmost location. So bottom is fine here, but we need to put right. And this is going to be for the vertical topmost location. And that means that this bottom has to change into a top. Now if I'm going to save and refresh, we get these values here, but they should be aligned to right. Otherwise they just go off screen and outside of the axis area. So align, we have to change it from left to right. I just copied these values here. And refresh. And now it looks just fine. Let's test this with a larger chart already now to see if it really looks good. So I'm gonna go here on demo HTML and change the size here from 250, let's say, to 500, just for a quick test. Okay, oh, this is really nice. So I can definitely see these values here, I can read them properly, and I like how the margin and layout looks like. Let's revert to the small value because I'm able to test better in this way.
We'll next implement a way to offset the data when dragging it. The process will go like this. On mouse down, we record the mouse location. And on mouse move, we use the new mouse location to calculate the difference, the drag offset. We add this offset to the data offset on every mouse up. Now we want to see the end result as we drag as well. So we update the chart on mouse move by adding the two offsets.
Let's go back to chart.js and we are going to call a function called add event listeners. This will be a private method, again, that we implement right here. Add event listeners. And I'm going to take out some objects here from this using object destructuring. And let's begin with the on mouse down event listener. So canvas on mouse down is a new function given event as the parameter. And what we'll do here is get the mouse coordinate. But we have to remember that we are working with two kinds of coordinates here. We have the pixel coordinates and the data coordinates. And I want to work with data coordinates when making this functionality. So let's define data lock. And this is going to come from a function that we need to implement from getMouse method with event as the parameter, and we set true here, which means that we want to work with the data space. So this getMouse function will be able to work in two ways, either giving us the pixel coordinates or the data coordinates of the same mouse location. Let's log this to see if it works and begin to implement this getMouse method. Given the event and another parameter, by default this is going to work in the pixel space, but if we specify here true, then we are using the data space. And now we'll implement both of these functionalities. So let's first get the bounds of the canvas using getBounding client rect, and the pixel location is going to be the client x minus the left side of this rectangle. So client x is just the x location inside of the screen, but we need to use the bounding of the canvas, subtract from that, and then we get the x location within the canvas itself. And the same thing happens for client y minus rect top here. So this is the pixel location, and if data space is set to true, then we are going to calculate the location in data space. I'm going to call this data loc, and I will use math remap point from the pixel bounds to the data bounds using pixel loc, which we calculated earlier. And here we can return this data loc. Otherwise, outside of this if we get to this point, I just return pixel loc. And let's close this getMouse method. Now let's save this file, refresh the page. And if I click somewhere here, I'm going to see some coordinates. So these coordinates 5, 4, 7, 9, 2, these are kilometers corresponding to the location where I clicked. And 2, 3, 6, 8, this is the price corresponding to the location where I clicked. If I'm going to click somewhere here, I'm going to get those negative price values I mentioned previously. This location here should be pretty much the lower bounds if I can click precisely there. So yeah, I think this is pretty much correct. And then the upper bounds here getting close to 300,000 kilometers here, and the higher prices as well. Now we can start transforming the data. And for that, I actually want to keep a backup here of the original data bounds. So I'm just going to call this default data bounds. This is going to come in use later on, but this is just going to be equal to get data bounds, same as the other one, but this is the one that we are going to be transforming. This just stays to the original values. And to record how we are transforming the data, we are going to write here an object, data trans is equal to two properties, an offset. This is by default 0, 0. There is no offset when the chart is initialized, and a scale. By default, the scale is 1. This will control the zooming. Let's implement the drag functionality first. And for that, we're going to use another object here, drag info, from the start location, end location, and the offset. These are all attributes that we are going to use and will help us when implementing this functionality. We need to know where a drag starts, where it ends, and this offset is going to be the difference. And finally, I want to mark here if we are currently dragging or not using this other attribute. Now, in our method for adding event listeners, we are going to add to the structuring here this data trans and drag info. And we don't need this logging here anymore. Instead, I'm going to set here the drag info start location equal to this data log. So we are storing it inside of this object's start attribute, and we are also setting the dragging to true so that we know that we are dragging in the other event listeners, like this onMouseMove event listener that we are going to implement next. So here we can check if drag info is dragging and only then worry about this. And what we need to do is get the mouse location and figure out the offset from the drag start location that we had recorded on mouse down. And that will tell how to transform the data. So data log is this get mouse event true, same as above. And now we can set here the end location to be this data log. And the offset, we will need to implement some utility functions here also in the math.js file. And these will be subtract. I don't want to write different lines for x and y. And then to get the new offset, the one that we are going to apply on mouse up, we will use the math add function that we also need to define like this. Let's output this in the console for now. And implement these add and subtract methods in the math library. They are really easy ones. So let's add here math add 2 points or vectors, and we return here the addition on the first dimension and the addition on the second dimension. And for the subtract, I'm just going to copy this, rename this to subtract, and put a minus here instead. We are doing the vector subtraction. And now we can save and test. So if I'm going to click here and I'm going to start moving to the right, you can see how those numbers are changing. Not so much the second number because I'm moving to the right. And now when I'm going back to my original starting point, that left number is getting smaller again because this what we're printing now is the offset. And now it's back to 0 because I'm at the same x location that I started. So that's working for the x value, and then vertically it changes the value with respect to my starting point. So this is the offset that we are displaying here. And it's being added to this original offset, which is 0, 0. But this is going to change on mouse up. You'll see. Let me first remove this and write a function call here for updating the bounds. So I'm going to do this in another function. This will be update data bounds with this new offset that we are calculating here. And now I'm going to also redraw everything. Otherwise we don't see the effect. And here let's have the onMouseUp event listener. So this is going to be where we actually set the offset of the data transformation to the same thing that we computed here just for testing as we are dragging purposes. So I'm just going to do this like so. And this is also the place where we are setting dragging to false. Now to update the data bounds, we applied the offset on the default data bounds that we defined in the beginning. So I'm going to go here and say update data bounds with the given offset. And here I'm going to destructure and say data bounds and the default data bounds, but this name is so long that I'm going to refer to it using def. from this. And now I can set the left of the data bounds to be def.left plus the offset on the first dimension. And the same thing will go with the right, but using def right plus the offset on the x dimension. And now we handle the y dimensions for top with offset of 1 and bottom with offset of 1. That's it. Let's refresh and now try dragging. And something weird happens. This kind of jittering effect happens. And the reason this happens is because in this getMouse method, we are getting the location inside of the data space using this data bounds. But this is the thing that changes. And if we want to have a good behavior here, we need to use something static, like the default data bounds. Instead, it won't matter when we are doing this remapping, because essentially what we are doing up here is calculating the differences, and the differences in the same data space are what matter. So let's save this, refresh, and now dragging works just as expected. Time to do the zooming, and we'll use the mouse wheel for that. I'm gonna go at the bottom here and implement an unwheel event where we are going to get the direction in which we are moving the wheel by calculating the sign of this event delta y. I'll show you in the console. Let's plot here the direction and this delta y. Refresh. Let's make this console a little bigger. And now when I scroll up, but it has to be above the canvas, if I scroll up, I see that minus 125 and 1. So this 125 is the amount the wheel moves, and this 125 plus when we move the wheel downwards. But the important thing is this minus 1 and 1. So minus 1 we move upwards, and 1 when we move downwards. This is what we are going to be using, and we are going to transform the scale with the small fraction of 1. So I'm going to remove this debugging here and say this step is going to be 0.02, and the data transform scale, we add this direction multiplied by the step. And then we also do update bounds with the offset that we stored previously and this scale as well. And we draw. But now this update data bounds should accept here the scale as well as the second parameter. And where we are calling the update data bounds previously, here we should be able to specify the scale as well. Otherwise, this won't work. Like this. And now we can implement the scaling functionality here. For that, we are going to use the center of the data as a kind of a focal point. So let's define here the center, and it's going to be the left plus the right divided by 2, and the top plus bottom divided by 2, like this. And now we are going to modify the left, right, top, and bottom bounds according to this scale, the center, and the original value. So we are going to use lerp for that, and we are going to lerp in between the center, 0, and data bounds of left. So this is for the horizontal, using this scale. So when we are going to zoom in and the data is going to increase, this scale is going to reach this data bounds left earlier inside the screen. And when we zoom out, this is actually going to do extrapolation outside of the data zone. So we will get even beyond those bounds. You need to play with this to really understand how it's going to work in practice and debug some things if you're not familiar with these topics. But yeah, it will work. And we need to do the same thing now 3 more times. One we do for the right, and we also use the center of 0 here, but we lerp using the right side. And now we're going to do the top here, top, but we need to put 1. And here we do bottom, bottom with 1. Now let's save the file, refresh, and zoom in by moving the mouse wheel up, zoom out when moving the mouse wheel down. But I don't want that table to change like that when I'm zooming in the chart here. To fix this, we go up here and write prevent default. So this is going to prevent that functionality from happening. If I will refresh this and start zooming, nothing happens to the rest of the document. Now there is a problem. If I'm dragging the data like this, it's just fine. But if I'm going to zoom in and drag the data, you can see how it's moving faster than the mouse. And that's because of the scaling that is happening, and we need to apply it also when calculating the difference of the offset. So when we calculate here this difference using math.subtract, we are also going to do scaling. So we need a function that does math.scale, and let me align this. And here I'm going to pass the amount that we want to scale with. This is going to be a new function we need to implement here, and it's going to be a little bit different format than these other ones with add and subtract, because here we have a scalar value that is just a number, and this is a point, like these other points were previously. So what we do here is we return p of 0 times the scalar and p of 1 times the scalar, and that's it. Save the files, refresh the page. Now we zoom in, and when moving the data, it moves just as expected. There is still a problem. If I'm going to zoom in a lot, I'm still zooming in, but the data somehow flipped around and now it's going other direction. Now I'm zooming out, which is somehow zooming in for a moment, and then everything flips around. So I don't want this to happen. I'm going to clamp this zoom. It's what happens when you get negative values and then you just get this flipping effect happening. So I'm going to go back here where we are calculating this scale, and I'm going to clamp these values between, let's say, I think we can use this step as the minimum value, and the maximum value, let's set it to 2. I will write here the scale is equal to max between the step and min between 2 and the scale, like so. If you're not familiar with this usage of minimum and max to clamp between 2 values, like in this case between step and 2, give it some thought. You can also write this using an if statement, but this is much shorter, and if you get used to it, it becomes really clear. Let's save this, refresh, zoom in, And now at some point I can't zoom in anymore. So this zooming in is as much as it will go. And zooming out, I set there a value of 2, and this is what the value of 2 means. It means that essentially this whole data now fits in just half of this width and half of this height, or a quarter of the whole space. Now, there is something that can be still improved. When you're zooming in the data, it's somehow harder to zoom in here. I have to scroll the wheel a lot. And then when the zooming starts to happen, the zoom happens a little bit faster this time. Now, this has something to do with how the area and the lengths are related, something to do with the square root and the squaring. We can fix this here where we update the data bounds by squaring these scales, all of them, and not just times 2, so this is to the power 2. If I'm going to refresh this now and zoom in, now the zoom is going to affect visually the same amount all the time. Like the width and height of the data is going to always increase with the same amount, same number of pixels on each mouse move. Now let's start to play with the colors a little bit. I'm going to go to our draw samples method here, and let's destructure here also the label of this sample. So this is what tells us if it's a basic or a sports car, if you remember from earlier, this type here, basic or sports. And here in the options, we have a style for basic and a style for sport. So we are going to go back here and we are going to say, when drawing the point, let's set also the style according to this label. So this third parameter of draw point is going to be the color. And if I'm going to refresh now, then these look a little bit different because the basic cars are gray and the sport cars are red. These are more expensive. We can do better than this. I'm going to use emojis to display these instead of just circles. So let's go back to demo HTML here, and I'm going to change this so that this gray and red is the color, like this. And then we also are going to have another attribute here, text, like so. And here I'm going to paste emojis. I found these online, so this is just emoji for a car and emoji for a race car. Now I want my chart to have both behaviors, the circles and these emojis. So I'm going to specify here that I want the icon to come from this text attribute here. And now in chart.js, in the constructor, we need to take out also this icon value. So here I'm going to say this icon is the options icon so that I know which to use. And going back all the way down in draw samples here, I'm going to say switch depending on this icon. In the case it's text, I'm going to graphics draw text on the context. The text will be the styles label dot text, and the location is going to be the pixel location. Let's close this, let's break, and then the default here is going to be the same that we had previously. So this part like this, but here we need to specify dot color because now this is the object that contains either the text or the color. Let's add the break here as well and close the switch. Save, refresh, and now we get this. The icons are there, they just look kind of small. We could get them larger, like if we pass here size set to 20 maybe, refresh, then they do indeed look a little bit larger, but this transparency is not very good now. Maybe we can get a different value for it, like maybe 0.7, so they are more visible. I think now this is a little bit better. But I think these icons are just too complex. So I'm going to simplify them and also teach you a little bit about image processing using filters. And we're going to recolor these according to our original color scheme. So remember, the basic car was gray and the sport car is red. Now both of them are kind of reddish, and it's hard to tell them apart if they would be mixed together. So how would we do this? Well, we are going to say here that we want to use an image instead. But we need to implement the functionality to convert the text into an image ourselves. And we will call this functionality generate images from the styles, like this. So this is the function that we need to implement next. In graphics, I'm going to type here graphics generate images from the styles, and let's set the size for this image to the default of 20. I think this looked good. And here, let's loop through the styles like this. And I'm going to create a canvas, a small canvas where we are going to draw the text as we did previously, but it's going to be a canvas only for this specific emoji. So we do document create element canvas, and the width is going to be this size, this 20, the same for the height. And now the context, we need to get it using get context, and we begin a path. We align the text to center horizontally and text baseline to middle to align it vertically. We set the font according to this size in pixels, and I'm using Curia, but I don't think it matters very much since we work with emojis. And then we fill text in the middle of the canvas, of this small canvas. So this happens for each of the things defined in the styles. Every emoji has its own canvas, and we are drawing it separately. And afterwards, we are creating an image in the style, and this source is going to be the data coming from the canvas, like this. So this means that our objects from here, basic and sport, they will also have an image that is generated when this line of code executes. Let's go back to graphics and implement also a function for drawing an image, because we don't have that. So far we've been just drawing text. So having an image, how we draw it on the canvas. Draw image at the given location. We begin the path, and we use the draw image method of the canvas context with the specified image, and according to the location we subtract half the width of the image, half the height vertically, and we set the image width and image height, like so. We fill, and that's our draw image function here. Only difference from the one from the context is that the image is now centered at the location and the original size is preserved. Let's save this, go to chart.js, and down where we have our sample drawings, we can also check if this is going to be an image. We will support all functionalities, the image, the text, and default it will just draw points. So here we can say case image, then we call our newly defined function with the image from the styles according to the label at the pixel location. We break, refresh. Oh, an error. Looks like here where generating the images I have the wrong syntax. So here, instead of having a for style of styles, this is an object, it's not an array. So I need to do label in styles, and here I can say const style is equal to styles of label. Let me refresh, and now it should work, but it doesn't. And the reason is that these images are generated here immediately after this, and then the chart starts to draw itself. But the problem is that the images have not yet been generated here. It's an asynchronous thing. And if I were to drag here the chart, then they start to appear. So it's a little bit of a glitch. We could fix this by adding a small timeout here. They get generated really quickly. So let's do something about it. I'm going to write here a timeout for creating the chart. So let's say set timeout for doing this chart creation of 100 milliseconds. And now that problem is not going to happen anymore. And you can see it works just fine. But what did we do? It's essentially the same thing as before with a little bit of a bug. See here, if I'm going to zoom in, you can see this car is actually cropped a little bit. You don't see the end points of it. This happens because the size of the font here is vertical, and then the emoji itself can be wider than this. So I can fix it quickly by just putting here some extra padding. Let's refresh. And now you can see that these are good. But we can do more than this. We can style these a little bit differently. Before generating these images here, before fill text, I'm going to say filter grayscale of 1 or 100%. Let's save this, refresh, and now our data is gray all of a sudden. So we're transforming those emojis and giving them a different color, in this case, no color. And we can do even more than that. Like, for example, if the style says that the color should be red, then we can do a different filter. And I'm going to apply a sepia. Again, 100% here. Let's close this. Else, let's have this one be grayscale. So if I'm going to refresh this, you see it's a little bit different tint here. This sepia color for the race cars, which are supposed to be red. The sport car is red in our definition here. But sepia is not red. It's actually a different hue that we could control with another filter. I'm going to replace these double quotes here with backticks because I'm going to write on multiple lines different filters here, and I think this makes it clearer. Let's use hue rotate minus 45 degrees, but after we do the sepia. So grayscale has no hue, but sepia has some hue. And doing a rotate of minus 45 degrees is going to give us red. And this is red. It doesn't look very saturated, but we can fix that. We can add here another filter, saturate, save, refresh, and now it's even redder than before. And there are many others you can play with. For example, you can set the brightness 200%. I'm really going to make them appear bright this time. I can also set here contrast. Let's set it low. So I'm going to have a very low contrast here, 30%. And you can see how this style changed very much. The details are now missing because of the lower contrast. You can even apply these multiple times. Like, let's see what happens if we are going to apply brightness again after sepia. It's a little bit different. Let's add another contrast maybe at the end. A big one this time, 300%. Now this is very red. And this is what I'm going for. I want to see a kind of an icon here where it's really, really clear what color it is, but I can still distinguish the shape. So this is much better in my opinion. Now let me teach you how to make any kind of hue that you want. So I'm going to write here a hue value of -45. This is going to give you red. And let's include it here inside of our template literal like this. So this is now same as before, no change. We just have this as a parameter. I can teach you how hues work. So if we add here 60, save, refresh, we now get yellow. If we add 60 again, then this is green, 60 again, this is cyan, 60 again, this is blue, 60 again, this is magenta. And these are all the hues that I plan to support. Of course, you can add less things than 60 degrees there, but these are the basic colors that I'm going to support in this chart. And this -45 is just what sepia does. So sepia moves to that specific hue of 45 degrees. And we are subtracting it to cancel it out. A hue of 0 is red. So let's define now a kind of a hue map. And this is going to have a value for red, yellow, green, cyan, blue, and magenta, like this. And here we just consider the 45-degree offset, but then we add here the value of this color hue map depending on the color that we are specifying here, gray or red in this case. So I'm going to go back here and change this if statement here. Sometimes these colors are going to be recognized by this color hue map here, sometimes not. And when they're not, this hue is going to be not a number because this is undefined and then it will generate not a number. So what we can do here is say if it's not not a number, then we do this coloring here. Otherwise, we do this grayscale. Let's save, refresh, and we get now our chart with red and gray. But if we go back here and say that maybe we want the normal car to be cyan and the sport car to be magenta, and we refresh again, then these are changing color. And they work with all of them, yellow and green and blue and gray. Yeah, this is nice, but we are not done. I want to be able to select points here, to emphasize points when I'm hovering them and to select them by clicking on them. So let's do the emphasis first. I'm going to go to chart.js, and in the event listeners, where we have the onMouse move event listener, I want to emphasize the item I'm hovering over. It doesn't matter if we are dragging or not. It will be some functionality that will happen always here. And let's do it here at the end. So what I want to do here is start by getting the mouse location in pixel space. So I don't specify here true anymore. And now I want to get the pixel location of the sample points. So they have been so far only in data space, and let's just call these P points. And we do that by using the map function, and we convert each sample S by calling remap point from the data bounds to the pixel bounds using the value of this sample point, like this. So these are now our mouse location and our points, our samples in the pixel space. And with these, we can do a nearest search. Let's implement that in a second, but the function will be in math, get nearest. So from our mouse location, this p-loc, we are going to find a point in p points that is nearest to this p-loc. This is going to return the index of that point inside of this array, not the actual point. To get the actual point, the nearest sample to our mouse, we just do these samples of index. And let's log this to see if it works. But of course, we need to implement the getNearest function. So I'm going now to math, and at the bottom here, I will say getNearest location from the set of points. We begin the search with the minimum dist initialized to the maximum safe integer, a very, very large value, and then we're looking for the nearest index. Let's say this one is 0, the first index. And then we loop through all of the points and we take it out like this. And then I'm going to calculate the distance d using a distance function between the location and the point. We have to implement this, but it's really easy using the Pythagorean theorem. And here, if d is less than the minimum distance, we update the minimum distance and the nearest index. We close these and we return the nearest index. That's it, our nearest search, essentially a minimum search for the distances. And our distance function here, let's just put it up here next to these other operations. It's the distance between P1 and P2. It's the square root of the difference on x squared plus the difference on y squared. And that's the length of the hypotenuse in the triangle, where this is the length on the horizontal axis and this is the length on the vertical axis. Let's save this, refresh. Every time I'm moving the mouse here, I get a new item at the bottom, a new sample point displayed there, logged in the console. And you can see the label is sport up here, basic here. So it seems to work. But let's go back to chart.js, and instead of logging this, we are going to emphasize it on the chart. So let's remove the log, and we will store this nearest in an attribute of the class. So it will be nearest sample to mouse. Kind of a long name, but it is what it is. And let's define it somewhere here. Nearest sample to mouse is null. And I'm just going to go to our draw method and do something relatively quick and dirty for now. After drawing the samples, I'm going to check if there is a nearest sample to mouse. I'm going to call draw samples again, but now with full opacity, and let's pass here a parameter. Draw samples doesn't have a parameter yet, but we can pass the samples consisting of just the nearest sample to mouse. So notice here, it's an array containing nearest sample to mouse. And that's because here I'm going to make it have all the samples, the whole array there. And now this draw samples is going to get these samples not anymore from destructuring here, but as a parameter instead. Let's save this, refresh, and it doesn't work. I was expecting to see that sample always rising to the top and not transparent. I am forgetting to draw here. So in our on-mouse move event listener, we are only drawing if we are dragging. And now we have to draw all the time. So let's refresh. And you can see what I'm talking about. So the nearest sample, it's emphasized without the transparency this time. But I want to emphasize this in a nicer way, not just with this hack here. So I'm going to say here, emphasize sample. And I will remove this array from here. It's just going to have one parameter. Now, to emphasize the sample, we are going to specify here a parameter for the color, how we want the emphasize to happen, and I'm going to use white by default. And here, let's get the location of the point, but we are going to get it in the pixel space. And now we're going to draw a gradient. So we're going to draw using a radial gradient from this p-loc location. I'm spreading it to have two parameters there. And then the radius, the initial radius of the gradient will be 0. And then let's spread it again. The gradient will have both centers in the same location. And then I will just use the margin to avoid any other parameters here. So this will make a radial gradient centered at p-loc going all the way to the margin. And it will have two gradient stops. First one is going to be the color that we specify here. And the second one is going to be a transparent white, fully transparent white. So it's kind of like a glow happening where we are drawing this. And after that, we are going to draw point with our function that already exists there, but we are passing here two things, our gradient as the color, and the size here is relatively big. It's like twice the margin. I just like how this looks, you'll see. And then let's reuse this draw samples method again with this array syntax there. We just have one sample that we want to draw. We save this, refresh, and now we get this kind of effect where we have a little bit of a glowing orb behind the object that is emphasized. Now, a problem here is that it's going to emphasize something even if you're very far away from it, like this, and maybe it's something that you don't want to happen. You can also not unemphasize something in this way. So let's fix this. I'm going to go back to our event listener and here revert back to storing this inside of nearest. And we are going to rename that nearest sample to mouse to hovered sample. It makes a little bit more sense and it's even shorter. So this should have changed it everywhere. And going back to the place where we calculate our nearest here, let's calculate the distance. So the distance between our projected points in the pixel space and the mouse location, if this distance is less than half the margin, again I'm using some value here that is quite general and it should work. In practice, when the chart changes size, we don't need to bother about this as a parameter. Then we set the hovered sample to the nearest, otherwise we just set it to null. And in this way we can also de-emphasize something. So now what we get is this, and when we are not hovering it, it's not emphasizing anything. Let's implement selection next. So I'm going to go up here where we have our hovered sample, and let's add another attribute for selected sample. We set it to null like this. And let's do two things at once. I also want it to be possible to select something in the chart from outside the chart. Like if we are going to click things here in the table, the chart will select something. So for that we need to add here an onClick callback function. Let's say onClick, and I'm going to store it here in the attributes. It has the possibility to be null, so maybe we don't want this functionality. And if it exists, then we are going to handle this. So let me go back to our event listeners and add here an onClick event listener for the canvas. If there is a hovered sample, then we just set the selected sample to that hovered sample. And we also handle that onClick callback. So if there is an onClick passed to our chart, then call that function with this selected sample as a parameter. You'll see later how we use it with that table. And then we redraw. So now we have to also make this selected sample visible in a little bit different way. And I'm going to go back to our draw method here. And I'm going to copy this again here, but I will replace this with selected sample. And here, emphasize sample, selected sample, and let's use yellow for the emphasis. Let's save this, refresh, and now when I click, it's highlighted with yellow and it stays there. The hovering still works for the other items, but when we are selecting something here, it stays like this. It stays yellow. Okay? But we still haven't done that callback, like when we click something here, something should happen. And bidirectional, actually, I would like to see where this item is in the table when I click on it on the chart. So let's go back to our demo HTML, and here where we create our table, this tr right here, each row of this individual sample, I'm going to add an ID for this item. Let's call it sample underscore plus sample.id. And now we will implement the function that will handle the click, the one that will also pass to the chart. So let's put handle click here and implement this function somewhere here at the bottom. Handle click on a given sample. And what we will do is we will get the element with the ID of this sample, sample underscore plus that ID. So I'm talking about the row inside of the table now. And I'm going to say add a class for emphasis, emphasize. And let's also scroll the item into view. Maybe it's off screen, so we won't see the emphasis otherwise. I will set this behavior to auto. I think there's also smooth if you want a different behavior, but I like things to happen fast. And setting block to center will move it in the middle of the page, otherwise it's going to be at the top. So let's close this and create our emphasize class here. So let's go to style CSS and just make it yellow, kind of like how the selection is on the chart as well. So background color yellow, and let's save this, refresh. And now when I'm going to click on the chart, it moved to this specific item that is also now still emphasized on the chart. And this happens with all of the things. They get emphasized using yellow, and then, oops, we have a problem. The emphasis is not removed when clicking on something else. So that's still something that we need to fix. We go back to demo HTML and we can write here query selector all, and let's select all the things with the class emphasize. Now I'm doing this query selector and then I'm spreading this into an array because I want then to use a for each syntax to go through all of the elements E and then say that the class list should remove emphasize. So this is going to fix that problem. I'm not going to test anymore, I know it works. But what I will do is implement the bidirectional functionality. Like now if I click here, nothing happens with the chart. So back here where we are making our table row, I'm going to say on click is equal to handle click on the sample. It's the same function essentially. Now let's save this, refresh, and when we click, it jumps to the middle of the screen. This is something that I don't like. I mean, if I click on something, I expect it just to stay there. But now when I click on this 700 from here, it just jumped in the middle of the screen. So not very good. We will fix this by passing here a parameter to handle click, which will do scroll only if necessary. So let's do here like so. Okay, if I refresh now, it just makes it yellow there. And you can see that this part of the code also works, but we still don't get it selected on the chart. So we'll do that. We have to go here and say chart select sample, this sample, and we have to implement this functionality. But there's one problem first, because chart is not accessible here because of this timeout trick we did previously. So we should take it out here, maybe like so, for testing. Normally you would implement this part for the image generation and have some kind of on-complete event handler when all the images are generated, have a kind of progress indicator there, but in general this is handled by something else, not the chart system itself. So I'm not going to bother with that in this tutorial. So our select sample function inside of the chart.js is going to be public this time. So select sample, sample, this selected sample is equal to sample, and this draw. Refresh. And when we click on these items now, we see them selected on the chart as well. If you want to implement hovering functionality in the same way, you can. I think it's overkill, so I'm happy with this. There's one thing that I don't like very much, how this data is above the axis labels. So maybe we'll fix this and also add some kind of cropping. Let's do this last part. I'm going to move this draw axis to the end. And inside the function, I'm going to do a sequence of clear rectangles, one at the top, one on the left, one on the right, and one on the bottom. Clear rect from 0, 0 with the canvas width and the margin. Then again with the 0, 0 with the margin and the canvas height. Then with the canvas width minus the margin, 0 and the margin and canvas height. And finally, from 0, canvas height minus margin, and then this canvas width and the margin. Let's save this, refresh, and now the data stays contained inside that kind of region there. Okay, let's test in full screen now. So it looks like this, but I'm going to make the chart larger. Maybe here in the options I'm going to put 600. Okay, nice. I think we can have a little bit bigger margin, but not much. Maybe 11%. Not a big difference. Now refresh. Yeah, I'm happy with this. Let's try to break it. Maybe there's some hidden bug somewhere here. Something happened. If I'm dragging something, if I'm clicking something, just clicking something, and then zooming, something weird happens. And I think I know what's wrong. Here, this drag info, the start, end, and the offset, we don't reset them on mouse up. I think this is going to solve this problem. So here, where we're setting dragging to false, let's reset the end and the offset to 0, 0. The offset is the important part. Let's save this, refresh. Seems to work, but I think I found another problem. Something else I want to fix is if I'm dragging the chart now, it's gonna select something else, and maybe we don't want that. Maybe we just want to zoom in on this, pan the chart around, and new items get selected all the time. I only want to select something if I click on it without dragging. For that we go here on click, and we check to see if there is any drag offset. For that I'm going to implement equals functionality for points in math. But let's just use it here first as equals between the offset of the drag and 0, 0. And if so, we return. We don't allow this other functionality to happen. Now in math.js, at the top here, we will write math.equals p1, p2, and we just return if the first and second components are equal, like this. Now we save the files, refresh the page, and if we click, drag, and release, it still doesn't work. I think I know the reason. In chart.js, here the on mouse up conflicts with this click. It actually happens before the click, but it's no problem. We can get the same logic if we move this on mouse down here where we initialize the dragging. Let's save, refresh, and now click, drag, release, nothing happens. But if we click without dragging, we can still select things. And actually, I would like to be able to unselect things as well. Let's implement that too. I will go back down here on click. If we already have a selected sample equal to this hovered sample that we're clicking on, then let's deselect. So clicking on something toggles it essentially. Otherwise, same as before. But let's deselect something also if we click on empty space, like if we don't hover over anything. So here, do the same thing on else. And we now want to do these things regardless if we have clicked over a sample or not. So let me paste this here, save the file, and before we test, we still have to take care of something. This selected sample here can now be null. And this will conflict with what we have in demo HTML here. The handle click function down here will process its ID, and then we will be in trouble. What we want to do is first, if the sample is null, we de-emphasize everything and then return. So the functionality doesn't go down here where it uses the ID. Now, if we click the same sample, we can detect that by doing if the element contains this emphasize class, we can remove the emphasize class so that we can deselect something in the table as well. And then we can tell the chart here to select nothing, essentially. Let's return, and the code below here only happens if we click on something to select it. But we should still de-emphasize things here as previously for the logic to work. Let's save, refresh, and now if I'm going to click on something, it selects it. If I'm going to click on it again, it deselects it. Let's click on it one more time. It selects it. Let's click outside here. It deselects it. Click somewhere here. And let's click on the table here. This also works. Yeah, everything is fine. I thought we fixed this. The data is now moving again faster than the mouse. Oh, I think in chart.js, when we scale the offset here, we scale using the scale value from data trans. But when we updated here for the zoom to work better, we had to raise this to the second power. And we need to do the same thing here as well for consistency. Let's save this, refresh. Yeah. Now I think we're good. Let's test the transparency again to see how it looks like after all these updates. And actually, let's take this out from the options as well. It's better like that. I'm going to write here that the transparency is coming from the options, or let's have them opaque if not defined. So if I'm going to save this and refresh, they are now completely opaque here, no transparency at all. But if we go to demo HTML and pass to the options here some transparency, say 40%, let's save this, refresh, the samples are now even more transparent than before. Everything seems to work.
Did you follow along? Great. Please like this video if you learned something today and share it with others so they can learn as well. And if you got stuck somewhere, ask and we'll figure it out. You can also take my version from GitHub and compare. For the brave ones out there, think you can optimize the chart? There are many things to do, like when moving the mouse over it to show the emphasis, it redraws every sample on each frame. It's really demanding. You can avoid that using a transparent canvas on top, where you only draw the emphasis. Think you can do that? Great. How about the next one? When dragging the data around, you also don't need to redraw every sample one by one. You can draw everything once as an image, and only pan that image around like this. You also need to update the values here somehow. Think you can do that? Really? Wow, then the only time we redraw all the samples is when zooming, and it's not such a big deal, I think. What else? Touch support would also be nice. Maybe the size of the markers can be an option. I don't know. Do whatever you want. It's your component now. See you guys.